Hello again. I'm going to tackle another form of factoring. Last time I showed you how to do the upside down division bar bracket factoring. Prime factorization through, finding prime numbers that would divide into larger numbers to find all your factors of a specific number. This is a little bit different. It's a tree format. It's a branching format. You don't have to worry about finding a prime number to divide into your original, your beginning number. You can use multiples of 10, 20, 8, and branch out like a family tree almost. So I've got 24 and 36 and 70 here as my examples, and I have not rehearsed this. So if I screw up, you'll see it. Okay, we're gonna start with 24. 6 times 4 is 24. So I'm gonna go ahead and branch out. Doop, doop. 6 times 4 is 24. And I'm gonna guess that you can assume the next step is gonna be I'm gonna take 6. I'm gonna branch out from there. And the two factors that go into 6 are 2 and 3. They're prime. We can go no farther. So now I've got to go back up and deal with 4. 4 has, once again, only two factors that I can deal with at this point, and that's 2 and 2. So my prime factorization, the expression for the prime factors of 24, is going to be 3 times 2 times 2 times 2, or 2 to the third, because we have 3 2's, times 3. And if I can go ahead and show you, if we do it the upside down division bar format, it'll end up being the same. So I'm going to go ahead and do that. And 2 goes into 24 twice, and it ends up giving us 12. And another prime number that I can stuff into 12 is 2, and it goes in there 6 times. And we're going to do 2 again. And 2 goes into 6 3 times. So you end up with the same prime factors and the same factors. You have 24, 6, 4, 2, and 3. 24, okay, 12's not in here. You could have gone 12. That's one of those things that, you do miss that in this branching format. You don't get every single possible factor. 36, I like 6 times 6. It's like blackjack. 6 breaks down into 3 and 3, as does this one. 70, you can do it by 5, you can do it by 10, you can do it by 7, all sorts of wonderful different ways. Let's do it by, let's say 7. So 7 times 10 gives us 70, which is up here. 7's a prime number, so I don't have to branch any further on that side of this. I do have to handle the 10, and that's going to break down into, guess it, 2 and 5, which are both prime numbers. So we've gone as far as we can with that. Now we've got a big number over here. Ooh, 1,000, right? You could do 10 times 100. You could do 2 times 500. That would actually be kind of interesting. There's different ways you can do this. You could do 4 times 250. So, whatever pops into your head and gives you a warm fuzzy. There's certain numbers that people can deal with that are, easily grasped. Like, I spent a lot of my life in the computer world, so I'm good with multiples of 8. I can go up to 512, 1024, just based on memory allotments and allocations and stuff. Other people can't do that. Some people are better with multiples of 10 or counting by 7s. So whatever's most comfortable. You pick the number that's going to be easiest for you to handle, but with a number like 1000, you have all sorts of different options for this. So we're going to go, heck, let's go 4 times 250. Because that's really not, you know, what somebody would probably pick standard. 4 breaks down into 2. 250. Well, 25 obviously goes into here because you've got this 25 right here with a 0. It's not like 251. 25 wouldn't be able to go into that. So 25 would go in here 10 times, and that would give us 250. So let's break it down that way, because that's going to really extend this little branch we've got going, and allow me to continue it a little bit more, so you guys who are watching this video have more opportunity to see what's going on. 25. Can't really do much with that. 2 won't go into it. 3 won't go into it. 5 will go into it. So we're stuck there. It's going to be 5 and 5. 10, once again, you can't really do much with it. You've got 2 prime factors that make up 10. 2 and 5. If you remember from my last video, determining things that are dividable by 3, 72, for instance, that's a 2. Looking at that, it's kind of hard to tell whether or not it's dividable by certain numbers. Obviously, it's going to be dividable by 2 because it's an even number. But if we want to get a bigger chunk out of it, break it down into, you know, bigger pieces, fewer big pieces, you want to find a larger number that can go into it. And by adding the 2 numbers, 7 and 2, that make up 72 together, you can find a number that hopefully is a multiple of 3. 7 plus 2 equals 9, and 3 does indeed go into 9. So we know that 3 will also go into 72. It's just a neat trick that I like to remind people of, because it helps like some of the weird numbers out there that are hard to mentally factor or multiply in your head. Knowing these little tricks around 3, I think 7's another one, where if you know some of these little scammer techniques, you can really streamline your math and it becomes less intimidating. And much more manageable. The main thing for math and getting into it and getting started is to take your time, be incredibly neat and organized and precise, and just basically set up a routine, a repeatable routine that's not too, you know, strenuous or tedious, and just go over it again and again and again. It will get easier. It will become less scary, and one day you will eventually learn to love it. And that's it for branch factoring. If you have any questions, feel free to leave comments. That would be neat, my first YouTube comment. But I'm willing to help you guys with math if you need it. Alright, I will talk to you later. Bye.